Hi. In this tutorial, I'm going to show you how to find this 3 by 3 rotation matrix between two frames. So suppose you have a frame, a coordinate system, which is like this. So this notation, a circle with a dot inside, that indicates this axis is perpendicular to the plane, and it's the positive direction is outward the plane. And I hope you know that this right hand full notation, that if this is your right hand, if this is your thumb, and this is your index finger, middle finger, and your pinky, your thumb's gonna point to the direction of Z, your middle finger gonna be Y, and your index finger gonna point toward direction X. So it's gonna be something like that. This is Y, Z, X. So in this case we have I cannot show you exactly, but something like this. As you can see, X is toward the plane, Z is upward, and Y is in this direction. So this is a right hand notation for finding the orientation of the axis. And obviously, you know the other right hand rule, that if you want to find the positive direction of rotation, you need to put your thumb in the positive direction, and then this is going to be positive value for the rotation, this is going to be negative value. So if you turn half a pi plus half a pi, then you have a turn like this, and minus half a pi, you have a turn like this. So we know these two right hand rules. Okay, let's go to our problem. We have a frame like this, and we have a oval denoted by 1, and we have the second frame, which is like this. Okay, how did I get this this frame? I did some rotation. I applied some roll, pitch, and yaw, and I get from here to here. Well, in this case, I know what I did, but generally I don't know that. I can only see the frame, and I'm interested to find this 3 by 3 matrix, and from that I can find the roll, pitch, yaw. So let's first, let me just draw how did I get here. First I applied roll, and you know the order is important. First you have to apply roll, then pitch, then yaw. So half a pi roll. So a roll is rotation around x-axis. So the positive direction is in this way, so I have to rotate my axis like this, 90 degree, which gives me this. You can see why I have to rotate it like this. The Y gonna go up, the Z gonna be in this way, and the X still perpendicular to the plane. Okay, now I will apply pitch. Again, plus half a pi, and obviously you know that when you want to apply the pitch, now you have to, well, pitch is rotation around the y-axis, but the new y-axis, this one, not this one. So now if you want to rotate half a pi, you have to rotate your axis around this new y, not around this one. So do not turn it around this way because it's gonna be wrong. rotation. So if I turn it half a pi over the y-axis, so this is a positive direction, so I have to turn my frame like this, 90 degree, which gives me this one. I can just draw it here again. Z gonna be from this pose gonna be like this, so it's gonna be perpendicular to the plane, and the direction is gonna be outward the plane. X gonna lay this direction, and Y gonna be still the same pose. So basically I applied a roll and a pitch, and there is no yaw. Okay, now we're looking for this 3x3 rotation matrix. To get this 3x3 rotation matrix, all I have to do is have to write the inner product, this inner product of the these vectors together. So it's gonna be x2, x1, x2, y1, x2, z1, y2, x1, y2, y1, y2, z1, z2, x1, z2, y1, z2, z1. So basically I'm just writing the inner product of this axis of this frame and this frame. Okay, so let's populate this matrix. So as you can see, x1 here is in this direction and x2 is in this direction, so they are perpendicular. It's going to be 0. X2 and y1, you can see both of them in the same direction, so it's going to be 1. And you know that they're the unit axis, so the size is 1, so the inner product is only and in this case all of them are the angle between the vectors is either 0 or half a pi, so it's going to be always 0 or 1. X2, Z1. X2 is in this direction, Z1 is in this direction, so it's going to be 0. Y2, X1, 0, 0, 1, 1, 0, 0. Okay. Now let's check these matrix. Okay, let's say we have a vector in this frame, and we like to see what these matrices give us. Okay, I will write the pose of this vector in this frame. As you can see, we have only y and z, and x is 0, so it's 0, 1, 1. The pose, the pose of this vector in this frame gonna be okay. I'll write it down here. F1, F2. I have x and y. I don't have any z, so it's gonna be 1, 1, 0. Okay, so if now I multiple these matrix, these rotation matrix, by this vector, I should get this one, because RF1 is equal to F2. Okay, let's see if it's everything is correct. 0, 1, 0. 0, 0, 1, 1, 0, 0. Okay. So basically R multiplied by F1 0, 1, 1. Okay, so 0, 1, 0, so only 1. 0, 0, 1, and 0, 0, 0. Okay, and this is exactly what we had here. So that's the main approach for finding the rotation matrix when we can visually see the frame and we're interested to find this 3 by 3 matrix. Okay, thank you.